Okay, guys, we are working on lesson 1.3 today. So continuing and really just some very basic Algebra 1 review. Today focuses on algebraic expressions. So being able to write those expressions using variables. So example 1, leading right into that, what algebraic expression models the word phrase 7 fewer than a number x? Thoughts on what we would do here? An algebraic expression that models the word phrase 7 fewer than a number x. Jameson? Okay. Fewer subtraction, so how can we write this then? Okay, he says x minus 7. Do you like his answer? Okay. Is there another answer that works here? I'm not saying there is or there isn't. I'm asking you guys, so. So my question is, no one's going to say it for me. What about 7 minus x? Does it work? Yeah. Okay, so you guys realize, I think you're giving me this crazy, stupid look under those masks, like, yeah, duh, no, they're not the same, which is good. They're not the same. Just remember, subtraction cannot be reversed, right? There's a right way and a wrong way. And the right way here is x minus 7. Okay? If it's 7 fewer than something, that means you're taking 7 and subtracting from it. So if, say, x is 10, then 10 minus 7 is 3. Okay? 7 minus x, well, that'd be 7 minus 10, which is negative 3, which is not the same thing. Okay? Good. Next one. What algebraic expression models the word phrase 2 times the sum of a and b? What do you think, Alyssa? How do you want me to write that? So she's saying 2 times a plus b, and she says, do I put a plus b in parentheses? So I'm taking that. That's what Alyssa was trying to get me to write there. Yes or no? Yeah? Okay. Do the parentheses have to be there? No. Is saying 2 times a plus b, is that the same? No, it's not the same, is it? Because in this one, we add a and b and then multiply by 2. In this one over here, we multiply and then add. So which one's the correct one? The first one again. Because it's 2 times the sum of something, that's going to indicate you want parentheses. I threw in a multiplication dot just because I thought it would make you guys happy. Do I have to have the multiplication dot? Absolutely not. That multiplication dot is unnecessary. Could I put a multiplication x? Nope. I would count multiplication x wrong right here. And why am I going to count multiplication x wrong in this situation? Yeah. If you put a multiplication x here, is it a multiplication x or is it a variable x? Okay. We don't know. And so you are at that point in your lives, and you've already been taught this, you don't ever get to use multiplication x's anymore, do you? Okay. So, okay, questions on that section? Oh, I know something that didn't come up there. Yeah, we'll talk about it later. Okay, problem 2. You start with $20 and save $6 each week. What algebraic expression models the total amount you save? So you start with 20. You save $6 each week. Again, I'm asking for algebraic expression that models this. Okay, what do you think, Ezra? Okay, he says 20 plus 6x. You like his 20 plus 6x? Because what's he doing? He says, okay, you start with 20, so there's my 20. You save $6 each week, so that means you are adding $6 each week. So what does this X stand for? The number of weeks. Okay. I realize it didn't say to, but I am going to define my variable, meaning Ezra chose to use X. So I'm going to state, what did that X stand for? And that X, let X equal number of weeks. Okay? Any other ways to write this answer? Could we switch this one? If you prefer, could you have said 6x plus 20? Yes, you can. Okay, both work. In this situation, neither one is more correct than the other. I think some of you naturally go, okay, they said start with 20, so you started with 20. Others of you are going to say, oh, but I like to have my variable first, so I'm going to put my 6x first. I would accept either or there. Okay, second one in this section. You had $150, but you were spending $2 each day. What algebraic expression models this situation? Natalie? Okay. She says 150 minus 2x. Are we okay with this one? Okay. So it's you had 150, you're spending $2 a day. So now we are subtracting $2 a day. What about 2x minus 150? No, because that is negative 150, and then adding $2 a day is essentially what that is. So again, example where subtraction cannot be reversed. What does my x stand for here? Okay, number of days. So let x equal number of days. And I went with what you guys said. Did it have to be x? No, it doesn't have to be x. It can be, but it doesn't have to be. Okay? Questions on this section? Okay. I'm going to try and keep us moving along then. Example 3. What is the value of the expression for the given values of the variables? So our problem A is 7 times the quantity A plus 4 plus 3B minus 8. And then it says for A equals negative 4, B equals 5. They want the value of the expression for the given values. What does step 1 need to be? Okay. Put these values in, yes? Before you start working this problem, take a moment and write the problem out with the variables in. I'm not going to say it's not doable otherwise, but it'll keep you organized. So if I rewrite this, substituting my A and B in, 7, parentheses, A, which is negative 4 plus 4, plus 3 times B, which is 5, minus 8. Okay. Well, where do we start? Okay. Parentheses? Why parentheses, Mackenzie? Okay. She says PEMDAS. If I say because Aunt Sally says so, do you guys know what that means? Because I tend to refer to Aunt Sally a lot.
Addition, subtraction.
Yeah. When I say Aunt Sally, because Aunt Sally's reminding us to do this, and I use that on and off throughout the class or the year. You guys have learned more PEMDAS, okay, and you have your, okay. I say, please excuse my dear Aunt Sally, and I'm just going to go with that's probably old school and what I was taught. Okay? But whether you think PEMDAS, whether you think, please excuse my dear Aunt Sally, what's P stand for? Parentheses. Then E is exponents. And then what? Multiplication, division. And what about multiplication, division? Together in order from left to right. And then addition and subtraction, again, together in order from left to right. That sounds familiar, yes? If you've made it this far, you've not made it through math this far without hearing about this. So that means, back to what they were telling me, start with the parentheses. Negative 4 plus 4 is 0. So now I have 7 times 0 plus 3 times 5 minus 8. Now what? Multiplication. Did parentheses, no exponents, multiply and divide. So 7 times 0, 0. 3 times 5, 15, minus 8. So 0 plus 15 minus 8 is 7. Nothing shocking there, right? Old news, you've been doing this. We just got to review, get our math skills up and going. Okay, let's try B if you're ready. X over 2 plus y squared, where x is 1 and y is 1/2. So step 1 is to plug them in, substitute those values in. So x over 2, 1 over 2 plus y squared, so 1/2 squared. Okay? Where do we start? Exponents. Can you guys do this without a calculator with me? Yes, you can. First of all, what does 1/2 squared mean? Okay, so I heard 0.5 times 0.5. Or honestly, I don't want to grab my calculator. I don't want to get it. So instead of thinking 0.5 times 0.5, I'm going to think 1/2 times 1/2. Yes? This is easy. You don't have to have a calculator for this problem. How do you do 1/2 times 1/2? How do you multiply fractions? You just multiply straight across, right? Top times top, bottom times bottom. It's not a difficult thing, guys. This one's doable. It's easy numbers. 1 times 1, 1. 2 times 2, 4. So what is squared? 1/4. So I now have 1/2 plus 1/4. Those of you that didn't want to listen to me, you had to use that calculator. You probably have 0.5 plus 0.25, right? Again, you don't need a calculator for this one. Well, it has to be true to add this 1/2 and 1/4 if I'm staying in fractions like I want to. Yeah, common denominator. What is the common denominator between 2 and 4? 2 and 4 both go into 4. So that means 1/4 gets to stay 1/4. How do I make 1/2 into so many fourths? You multiply by 2. If I multiply the bottom by 2, multiply the top by 2. And 1 times 2 is 2. 2/4 plus 1/4, 3/4. You can't tell me that was an impossible problem without a calculator. I'm going to accuse you of being lazy then. It's doable. May not want to, but it is doable. Okay, let's look at C. What's the first thing I'm going to do on C? Plug in those values, right? So 2 times 6 squared minus negative 3 squared all over 3. Where do I go now? Okay. Starting those parentheses, right? So that 2 staying out front. What do I do in those parentheses? Okay, 6 squared, 6 times 6 is 36. Minus, I'll leave that minus as is, negative 3 squared. Negative 3 times negative 3. Negative times negative makes it positive. 3 times 3 makes it 9. So my problem looks like this, where I now have 2 times the quantity, 36 minus 9, all over 3. Now what? Okay. Finish inside those parentheses. Subtract 9 from 36. So now I have 2 times 27, all over 3. Now what? Okay. 2 times 27, 54. 54 divided by 3. Close. Go up 1. Now, side note. Up until this point right here, we kind of had to take those steps, didn't we? Now, order of operations traditionally says 2 times 27, then divide by 3, yes? However, 2 times 27, some of you probably started to struggle there and said, I don't know what that is without some, really serious thinking. And then on top of it, you had to do 54 divided by 3, which to do mental math there without writing it down, that's really getting, you really have to stress your brain there. Okay, back up. Here's what I do on this one, because I look for ways that I can avoid grabbing the calculator. What do you know about 27 divided by 3? That's 9. And then you would have what? 2 times 9, which is 18. Okay? That's perfectly legal as well. It is. It's perfectly legal. You know what I mean. So, you're not going to go to math jail for it. Is that better? Okay. Questions there? Got what you need? Okay. Problem 4. In football, a touchdown is worth 6 points. An extra point kick is worth 1 point, and a field goal is worth 3 points. What algebraic expression represents the total number of points in a game given those 3 ways to score points? Stop reading right there. Okay? In other words, I'm ignoring that last sentence right now because I have a question to answer on the previous sentence. What algebraic expression represents the total number of points in a game given those 3 ways to score? Thoughts? I partially like it. Okay. Okay, so instead of having all x's, you're going to have different variables. Okay, because it's not all the same. If we use x, x, and x each time, it's not all the same. So, what do we need variables to represent? Okay, touchdown. What do you want for touchdown? Okay, so I'm going to say let t equal touchdown. What else do we need a letter for? Extra point kick. What do you want to use for your extra point kick? E. So I'm going to use E for my extra point. What else do I need a variable for? Field goals. What do you want to use for a field goal? Okay. Ezra says F. Do we all have to use the same letters? No. Pick whatever makes you happy there. So now using those three variables I just defined, write an expression. So, 6 points a touchdown. How many touchdowns? No. We don't know right now. For what I'm doing, 6t. Plus, extra points are worth 1 point. How many extra points? We don't know. We're going to use e. Officially, it's 1 times e. But, I don't know about you guys. I'd rather just write e. Plus, field goals are 3. We don't know how many right now, so we're going to say 3f. What we just wrote right here answers the question of what algebraic expression. That's our algebraic expression. That's the part, had I not stopped you guys, you would have just skipped over and moved on to the end. I get it. That's why I said stop reading. Okay, now read that last sentence that I wouldn't let you read about. Suppose a football team scores 3 touchdowns, 2 extra point kicks, and 5 field goals. What is the score? Now what do we do? Plug them in. Same thing you were doing on the other problems, right? So 6 times how many touchdowns? 3. Plus E, 2 extra point kicks. That's like 2 times 1 if you want. Plus 3 times 5 field goals. Do some math. What happens? 18 plus 2 plus 15, which is 35. 35 what? Points. Okay, we've got 4 problems left on the back side to do. Combine like terms. What is a simpler form of each expression? 7x squared plus 3y squared plus 2y squared minus 4x squared. Thoughts on what I can do here? Mackenzie?
Subtract 4 from 7 and get 3x squared.
Okay. She says subtract 4 from 7 and get 3x squared. Those two can go together because they are like terms. They're x squared. So it's 7x squared. Notice there's a minus in front of the 4, so minus 4x squared. So that's 3x squared. Good. What else? Yeah. We've got 3y squared plus 2y squared, which is 5y squared. What is 3x squared plus 5y squared? What is it? Can I add those? No. They're not like terms. You're done right there. So when I say what is it, it's that right there. 3x squared plus 5y squared. Okay, B. You've got the negative of 3k plus m plus 2 times k minus m. 4m, excuse me. What's got to be my first step here? Yeah, we've got those parentheses. So we're going to have to distribute the 2. What else are we going to have to do? Yeah, this negative out front also requires a distributive property. This is, if you prefer, it's like thinking about there being a negative 1 out there. Okay? Or what happens when you multiply everything by a negative? Just changes those signs, right? And so you're going to take this negative and multiply everything. So negative times 3k is going to be Negative 3k. Negative times plus m minus m. Now plus 2 times k. So plus 2k. Plus 2 times minus 4m. What's that going to be? Minus what? Minus 8m. Realize it was plus times minus, so I made it a minus, right? Okay, am I done? No. We gotta clean it up. We gotta keep going. What goes together? Yeah, negative 3k plus 2k is going to be negative 1k, or I just wrote negative k. And minus m minus 8m. So negative m minus 8m. Minus 9m, because it's like negative 1 minus 8. And what about negative k minus 9m? Final answer. Okay. What about C? Negative 4j squared minus 7k plus 5j plus f squared. What? Okay, so k, that's the only k. F squared is the only f squared. We have a j squared and a j. He wants me to put them together. Are j squared and j the same variable pieces? And that's the trick here, right? What am I trying to get you guys with? So j and j squared, those don't go together. So does anything go together? No. There's nothing you can do here. You can write out the answer as is. Negative 4j squared minus 7k plus 5j plus f squared. That's about the best you can do, is just rewrite out the same problem. Okay, you ready for the last one? What happens with the first parenthesis? Okay, distribute the negative. So that first parenthesis, instead of being 8a plus 3b, is going to be negative 8a minus 3b. On the second parenthesis, distribute the 10. It becomes plus 20a minus 50b. And final step. Negative 8a goes with 20a. What's negative 8 plus 20? 12a. And then minus 3b minus 50b is going to be minus 53b. Okay, guys. There you go. Your homework is in the workbook page. It's practice, so find the page that says practice. 1.3 workbook. And it's 1 through 21. Have that done and ready to go for tomorrow. Okay? And I will say, good news is it is looking like we will have iPads by the time we get to Chapter 2. Okay? So we should, for Chapter 2, then be in Math Excel.